Good afternoon, students. This is Miss Hayden, and today I have screencasted our lesson. Excuse me, I'm sorry. So, let me tell you what is going to be happening today, and because I know you're all very excited for the electricity lab. And what's going to happen is tomorrow, when I'm there, obviously, we are going to finish up our notes on electric currents and electric circuits. One class will also be presenting their mini projects. And then we're going to get started on our electric circuit labs tomorrow. Okay? When we are done our electric circuit labs, and what we'll be doing for the rest of the year is our science skills. We'll be working on our science skills. And to be more specific, we'll be talking about how to organize and interpret large amounts of data. Okay? And that's what we're going to get started on today. Okay, so we're going to put our electric circuit lessons on hold because I'm not there to help facilitate the lab, and we're going to get started on what we'll be doing for the rest of the year. Okay, so that's what's happening today. So, today's drill question was, when should you use a line graph and when should you use a bar graph? Now, this is something we've talked about earlier in the year, and if you remember, we use a line graph to talk about as a way to display data's change, something's change over time. Okay, how data changes over time. So if you guys remember, we looked at, we talked about how a line graph would be perfect to display how much money a company lost and got over the course of the year. Remember, we talked about how it kind of looked zigzaggy. All right, and then we use a bar graph when we are comparing and contrasting two or more different things. Two or more different data points. Okay? So, today we are going to be learning how to make a line plot. Now let me start off by saying line plots are really easy. You've probably done them before, and they're very similar to bar graphs. Oh, oops. Sorry about that, guys. Let's try that one more time. There we go. Okay, so this is an example of a line plot. Okay, and what a line plot does is measure the frequency of something happening. This is what I mean. Over here on the right, I have the number of projects students completed in a class. So this student right here completed 2 projects. This number 4 represents a student who completed 4 projects. This student completed 3 projects, and this student completed 0 projects, which is not good. Okay? And all we're doing is we're not doing any math. We're not finding any averages yet. All we're doing is just plotting the points. We're plotting the number of students who completed the number of projects. So, for example, okay, I'll pick 0 because it's the easiest one to see here. One student completed 0 projects. So 0 has 1 student. Each X represents a student. Okay, one student completed 5 projects. So when we'd make this graph, we'd plot 1 student for 5. Okay, so let's just go ahead and get right into making our own. So over here, I have some data, okay, and this is data from earlier in the year when we completed our speed lab. Okay, and this is the rounded raw data of this speed that students completed. So this student skipped from my door to the trash can and back in 30 seconds. This student skipped from my door to the trash can and back in 31 seconds. Okay, so let's go ahead and talk about the first thing you need to do when you make a line plot is to make your original scale here, this original number line. And the best thing to do is to look for your smallest data point and your largest data point, because then you can just go through and fill in everything in between. So when I first made this, I went through and looked for the smallest number here, which was 30, and marked that up. And then I went through and looked for my largest and put that there, okay, and then filled in everything in between. So let's just go ahead and make our line plot, okay? So one student got completed skipping in 30 seconds. So I'm going to put an X here. Now your X is better be neater than mine, okay? And it's always good to go off and mark on the original raw data so that you don't do something twice. So then another student completed it in 31 seconds. Another student completed it in 32. So like I said, each X represents one student. Another student did it in 33. And finally, we have another student here who did it in 31, okay? I'm just going to put that second X on top of my first X, okay? So this is just from what I plotted just now, okay? Two students, I can tell, two students have skipped up and down the hall in 31 seconds. Alright, so what I'd like you guys to do is go ahead and complete this, and then we're going to talk about how to interpret it.